Hello everyone. In this presentation, we'll be looking about neural networks. Neural networks are revolutionizing machine learning, enabling computers to learn and solve complex problems by mimicking the human brain structure and function. Join us and we will delve into the fundamental concepts and practical applications of this transformative technology. Firstly, let's unveil the architecture of neural networks. The architecture of neural network consists of interconnected layers of artificial neurons, each processing information and transmitting it to a subsequent layers. They learn by adjusting the weights of these common connections. Basically, a neural networks look alike like a neuron in a human body. It is a look alike of that neuron. Unlike it functions exactly same and mimic the neuron connectivity as the human beings. Activation functions introduce non-linearity into the model, enabling the network to learn complex pattern. Common examples include sigmoid, ReLU, and TETH. Moving forward, let's see the building and training. How to train your neural network. Using Python, we can easily train a neural network. Python, renowned for its extensive ecosystem of libraries and frameworks, provides a powerful environment for developing and deploying neural networks. Key libraries such as TensorFlow and PyTorch offer comprehensive tools for model training and optimization. TensorFlow high-level API Keras simplifies the process, while PyTouch dynamic computation graph allows for greater flexibility in model designing and experimentations. These resources enables developers of all levels to create, train and evaluate sophisticated neural network architecture with ease. We will be seeing in the Python IDE for how to build neural network using TensorFlow library. Neural network are transforming industry. Now let's understand some more applications of neural network. It is used in image recognition. Neural network power image recognition in various fields including medical diagnosis, self-driving cars and security systems. Automatic car and security systems are a best example to use neural networks which train them on the basis of a human cyclic resource. Language processing. Natural language processing is a technique which is widely used in data science to train the models. They enable machines to understand and generate human languages, revolutionizing applications like chatbox, language translation, and text analysis like ChatGPT and uh, many AIs like Gamma AI, ChatGPT, Gemini uses all these language processing algorithms. Neural networks helps in building those algorithms. Predictive analytics. Neural networks are used to predict future outcomes based on historical data, improving business decisions and forecasting trends. Now let's look at the neural network code in our Python VS Code IDE. As you can see in my VS Code, I have imported some packages, common packages like NumPy, Pandas, etc. And also this time I have import TensorFlow.keras model, import sequential, TensorFlow.keras layers, TensorFlow.keras optimizers and utils. First step is to create synthetic data for binary classification, in which we are passing data types like x and y equals to make underscore classification, and under the parameters we are passing n samples and features and classes and random classes. Step 2 is to train or test split, as we have learned earlier how to train and test split. X underscore train, X underscore test, Y underscore train and Y underscore test equals to test underscore test equals to split, passing the parameter X, Y, test size and range. Third step is to standardize the data. Standardization of data is used by functions like standard scaler, scalar dot fit underscore transform and scalar dot transform. Scalar equals to standard scalar, x train equals to scalar dot fit underscore transform, and x test equals to scalar dot transform, passing the parameter x train and x test. Fourth step is to convert target variables to the categorical format. Y underscore train underscore cat for categorization conversion equals to 2 underscore categorical, passing the parameter y underscore train. Similarly, for test, we have passed the parameter test. Fifth step is to define the neural network model, which is a very crucial step. For defining, we use dense library function. Model equals to sequential, and under which we have passed dense and then respective parameters including input size, activation which hide the layer, and activation equals to relu which hide the layer, and activation equals to softmax which output layer up to 2 classes. Up until next is the step 6, which is the compile the model. Model.compiled is used here as a function and passing the value loss, categorical, characteristic, and matrices accuracy. The step 7 is to train the model. History equals to model.fit, passing the parameter x train and y train, categorical values, validation data, test and y test and x test. Steps 8 is to evaluate the model. Loss, accuracy, everything is evaluated here, and printing the desired test loss and test accuracy. Step 9 is to make predictions, which is very essential in the neural network model. Ypred is used here again, equals to model.predict and passing the parameter x test. Predicted classes np dot argmax and then passing the parameter ypred and x is equals to 1. Step 10 is to show the results obviously and printing the desired outcome as print 10 actual classes y test and printing 10 actual predicted classes predicted underscore classes. With this, we have completed the code of neural network 2. I hope you have understand the application and basics of neural networks in data science. We'll meet in the next video. Until, thank you.